So, this is my walkthrough of the 2005 SATS paper, Tier 4 to 6, Paper 2, which you're allowed to use a calculator for. Right. The first page, it's got some instructions, and it's got some formulae, if we needed to use those. Question 1. Each month, some people leave a gym, and some people join a gym. Diagram shows how many leave and how many join. Number of people leaving, months, and number of people joining. Which month the greatest number of people leave the gym? So leaving the gym, I'm looking for the biggest bar chart this way, and that is October. In September, more people joined the gym than left the gym. How many more? Right, in September, I can see that goes to 25. And over this side, I can see it's one less than the 15. Just check. 11, 12, 13, 14, 15. Yeah, one less than 15. So it's 14. I'm going to write down here 25, take the 14. And because I've got a calculator, 25 minus 14 equals 11. Okay, question 2. Is 3 a factor of 30? Yes. Explain how you know. 30 is a multiple of 3. Question 2b. I'm thinking of a number that is greater than 3. My number is a factor of 30. What could my number be? Give an example. Well, the factors of 30 are 1 and 30, 2 and 15, 3 and 10, 5 and 6. Greater than 3, well that's that, or that. Any of them, I'm going to write 15. It could be 5, it could be 6, it could be 10, it could be 30 as well. Cannot be 3, 2 or 1. 3 is not greater than 3. Question 3. Here's a sequence of shapes made with grey and white tiles. Shape 1, 2. Number of grey tiles is 2 times the shape number. So 1 times 2 is 2 greys. Number of white tiles, 2 times the shape number. Altogether, how many tiles would be in shape number 5? It would be 2 times 5 for the grey ones, and 2 times 5 for the white ones. 10, 10, 20 tiles in total. Altogether, how many tiles will be in shape number 15? Do the same again. 60 tiles. Write the missing number below. The total number of tiles equals something times the shape number. B, 4 times the shape number. Just checking. 4 times 5 is 20. 4 times 15 is 60. Question 4. A meal in a restaurant costs the same for each person. For 11 people, the total cost is 250. What is the total cost for 12 people? If I do 253 divided by 11, that's going to tell me what one person is. 253 divided by 11 comes to £23. I times that by 12, £276. Here's a rhombus. The dotted lines of the diagonal of the rhombus. Measure accurately the length of the diagonals. So, my ruler, line that up carefully so that's on the 0. Down there, I'm getting 6.8. 6 centimetres, and I'm getting 10.2 centimetres. You're allowed to be a millimetre out each way, so 6.5 or 6.7, 10.1 or 10.3. To find the area of the rhombus, multiply the lengths of the diagonals together and divide the answer by 2. Right, so here we go. 6.6 times 10.2. Then divide that by 2. I'm getting a weird answer there. Now, some calculators might have like an SD button that allows you to turn it into a decimal. Okay. I don't, so I'm going to press the format, and I'm going to go to decimal. Press that, and it comes up with 33.66. I'm also going to put in there centimetres squared. Because the area is measured in centimetres, so centimetres squared. Question 6. Survey showed these results about number of mobile phones used in the UK. Right, use the graph to write missing numbers below. Years going that way, number of phones in millions. 1992, there were about 1992. Oh, okay. If that's 10, that's 5. That's probably 2.5. I reckon that's about 2. 2 million mobile phones. 10 years later, there were about, so 10 years later than that would be 2002. Just 1, 2. Yep. And there were about 50 million mobile phones. From 1998 to 1999, the number of mobile phones increased by about, right, so 1998, that's 15, that's 10, about 13, and 1999 is here, about 24. 24 minus the 13, 11. Yep, you can see it on my screen there. Okay, question 7. Arrange all the numbers 1, 2, 3, 4 and 5 into 2 groups, so that doubling the sum of the first group gives the sum of the second group. There are 3 different ways the numbers can be arranged. The first is done for you. 5 over here, 1, 2, 3 and 4 over here. I'm going to stick with this trend. Because this is 5, I'm going to look at these numbers. Do any of these add up to 5? Well, 1 and 4 does. Put 1 and 4 there. And then I put 2, 3 and 5 in here. 1 add 4 makes 5. 2 add 3 add 5 makes 10. So that works. Doubling the sum of that gives you the sum of that. Keeping the same thing, I've also got 2 and 3 could come over here. Which means I would have 1, 4 and 5 over here. 2 add 3 makes 5. Double that is 10. 1 add 4 add 5 is 10. Doesn't matter which way round these 2 boxes go. Okay, 8. On the grid, draw a triangle with no right angles. A line going down there. And I'm going to do a line. Looks like this. And a line that looks like this. None of those are right angles. On the grid, draw a quadrilateral with no right angles. I'm going to draw a trapezium. You could also have drawn a kite. It looks like this. These 2 lengths are the same size. That goes all the way down there. Okay. Kite. It's a badly drawn kite, but you get the gist. They're meant to be the same length. They're meant to be the same length. You could also have had a parallelogram, like this. Rhombus. And that's parallel with that one. And that one's parallel with that one. A few different quadrilaterals you could have had. The last one. How many right angles does a shape on the grid have? It has one right angle. It is here. One right angle. Question 9. Look at the algebra grid. 2a, and it says add 3a is 5a. Yep, 3a, 4a, add them together, 7a. 5a, 7a is 12a. Complete the algebra grids below, simplifying each expression. Right, so 6k at 2k, 8k. 2k at a k is 3k. 8k at 3k is 11k. First one done. Second one's a little bit harder. It's got two terms here. 2a at 4a, 6a. 3b at 2b, 5b. 6a at 7a, 13a. 5b at 5b, b. I've got one more. So I've got to think, what do I add to 4a to make 7a? That'd be 3a. What do I add to 2b to make 5b? That'd be 3b. Question 10. Look at this information. In 1976, a man earned £16 each week. Pie chart shows how he spent his money. How much did the man spend on food each week? Now I can see here the pie chart's been broken up into 1, 2, 3, 4, 5, 6, 7, 8 equal bits. And here are 2 of the 8 equal bits. That's 2/8, otherwise known as 1/4. 1/4 of the amount of money he spent each week is £16. 1/4 of 16. 16 divided by 4, which is 4. Now look at this information. In 2002, a man earned £400 each week. One table shows how he spent his money. Rent, food, entertainment, other. Complete the pie chart, show how the man spent his money. Remember to label each sector of the pie chart. So this is 200 out of 400. Should simplify it down. If I'm not sure, I can do it on the calculator. Fraction button, 200 out of 400 will give me a half. So half of my pie chart is going to be rent. Then I've got 100 out of 400. Cancels down to a quarter. A quarter is going to go on food. Finally, these are both 50. So they're both the same. Got entertainment and other. So it should look something like that. Question 11. I want to buy 30 pens. 2 shops sell packs of pens. Supermarket, 5 pens for £6.25. Village shop, pack of 6 pens, £7.20. Which shop are the pens cheaper? You must show your working. Well, we've got 2 ways of showing this. I'm just going to draw a line down the middle. I'll show you both ways. First way is to go, right, I need to get 30 pens. How many of these would I need? Well, I'd need 6 lots of 5 to make 30. I'm going to do £6.25 times 6, because I would need 6 packs of those 5 pens. £6.25, 5 times 6, £37. That's the supermarket. Village shop. Well, they've got 6 packs of pens, so 6 lots of 5 to get 30. Do £7.20 times by 5. On here, £7.20 times by 5, £36. Which one's cheaper? It's the village shop. I said there were 2 ways of doing it. This one I made them both up to 30. But I could have found out how much 1 pen would be. To do that, I would do £6.25 divided by 5 to find out what 1 pen is. £6.25 divided by 5. That tells me it is £1.25. Or I could have done £7.20 divided by 6. That's £1.20. Which one's cheaper? £1.20. Each pen's £1.20. Village shop again. It doesn't matter which way you do it. There's 2 ways there. Question 12. A puts 2 white counters and 1 black counter in a bag. He's going to take 1 counter without looking. What's the probability the counter will be black? We've got 1 out of 3 counters. It's 1/3. That's it. Aidan puts the counter back in the bag, and then puts more black counters in the bag. He's going to take 1 counter without looking. Probability that the counter will now be black is 2/3. How many more black counters did Aidan put in the bag? Well, if its probability it's going to be black is now 2/3, that means the probability it's white is 1/3. Okay. I have 2 counters of white. Now, if I need to make a fraction, it's going to be equivalent to 1/3 from 2. I'd have to halve that. I'd have to halve this number to make that. If I do it backwards, 3 times 2, 6. I now know that there are 6 counters in total in the bag. We know that that one up there, was in there. That's 1 black one. How many more does he need? Well, we've got 2 white ones, and we've got 1 black one, and we've got 6 in total. We need another 3 black counters. That'd be 3 black counters, another black counter is 4, 2 white counters gives me a total of 6 counters in total. Question 13. Scale drawing shows the positions of London and Paris. From London to Paris, the angle from north is angle A. Measure accurately angle A. Special protractor here. Put my 0 on north. Okay. I'm going to measure round. Now I'm measuring round this way. That's the angle I'm measuring. So I go from 0. I go all the way down 10, 20, 30, 40, 50, 160 degrees. 160 degrees. Now when measuring degrees, you're allowed to be 1 degree off each side, so 159 or 161 also acceptable. On the scale drawing, 1 centimetre represents 50 kilometres. What's the distance in kilometres from London to Paris? I'll reel up and measure here from there. That is 7 centimetres. So it says 1 centimetre is 50 kilometres, which means that 7 centimetres times that by 7. 7 times 50 is 350. 350 kilometres. Okay. Part C. From The newspaper printed this information about London and Madrid. London to Madrid, the angle from north is 195 degrees clockwise. Madrid is 1,300 kilometres from London. Use a scale on a scale drawing. 1 centimetre represents 200 kilometres. Right. The first thing I'm going to do is I'm going to measure the angle from north, 195 degrees clockwise. Put my 0 on north again. There you go, just line it up. So that crosshair goes on London. Lining up my protractor so it points upwards like that. I'm going to measure round, going clockwise. I'll get to 195. Put a little mark there. 95. Take my protractor off. I'm now going to think about how many centimetres I'm going to need. 1 centimetre is 200 kilometres this time. And I want 1,300 kilometres. I need to work out what I need to multiply that by. I'll do that in reverse. 1,300 divided by 200. That will give me 6.5. I'm timesing that by 6.5. Means I need to times that by 6.5. Which would be 6.5 centimetres. I'm going to get a ruler. I'm going to line it up. The start of my ruler is there. It's going through that line. I'm going to draw a straight line. I'll get to 6.5. Okay. And then I'm going to put a cross and I'm going to write Madrid. There we go. So that was 6.5 centimetres that way. That was an angle 195 degrees. Next question, question 2. Work out the number of boys and girls in each class below. In 8M, there are 27 pupils. There are twice as many boys as girls. So, if I said there were X amount of girls, that means there's 2x amount of boys, because there's twice as many boys as girls. In total, 2x x is 3x, and that is 27. How would I get down to x? Well, that's 3 lots of x is 27. Divide both sides by 3. I remember me doing something like that. 27 divided by 3 is 9. That means there are 9 girls. 2 lots of 9 is 18 boys. I'm going to do the same thing here. There are 2 more boys than girls. Well, there's X amount of girls, and there's 2 more boys. So I've got the same amount of girls, but then 2 more. If I put that together, I get 2x plus 2 is the 28. Line down the middle. Take away the 2 from both sides. Get 2x, because that 2's gone now, equals 28, take away 2, is 26. Divide both sides by 2, x equals 13. That means there are 13 girls. There are 2 plus the 13 for boys. Finally, in 8T, there are 9 boys. The ratio of boys to girls is 1 to 2. 1 to 2, there are 9 boys. Remember, it says boys to girls, so boys, girls. 9 goes under the 1. What have I done to 1? Take it 9. Well, I've times it by 9. What do I do to 2? Well, I'm going to times that by 9 as well. 2 times 9 is 18. That means I've got 9 boys and I've got 18 girls. Question 15. There are 3 lines on a centimetre square grid. Draw 2 more lines on the grid to make a pentagon that has an area of 14 centimetres squared. Right, so I need to make 14 centimetres squared. Let's look at what I've got so far. 1, 2, 3, 4, 5, 6, 7, 8. Right, I need another 6 squares out of this lot somehow. Well, if I go 9, 10, 11, 12, I need 2 more squares. Okay. Draw a line down there. I'm going to draw a line across here. This is good because a pentagon is a 5-sided shape. 1, 2, 3, 4, 5 sides. Got 12 squares so far. 13 squares. 13 and a half squares. 14 squares. So they add up to make a whole square. Question 16. Use your calculator to work out the answers. Right, here's my calculator. Bracket 48 plus 57, those brackets, times brackets 61 minus 19, those brackets. 4, 4, 1, 0. Next one, I can actually put that in my fraction button. 48 at 57. Underneath it, 61 minus 19. 5 over 2. If I wanted as a decimal, do that. It would have been absolutely fine to leave it as a fraction as well. 2 over 5. Okay, question 17. Each year there's a tennis competition in Australia and another one in France. The table shows how much money was paid to the winner of the men's competition in each country in 2002. So I've got Australia, $1 million Australian dollars. In France, I've got 780,000 euros. Which country paid more money? You must show your working. Now, to start with, it looks like you get more in Australia. But then it does say £1 is the same as 2.70 Australian dollars. Where in France, £1 is the same as 154 euros. So let's work out what they both are in pounds. Australia, France. I've split the two up, so I can draw a line down the middle, and I'm keeping my working separate. Now turn that back into pounds. I'm going to divide it by the exchange rate. I'm going to do 1 million divided by 2.7. And I'll do it over here quickly. 1 million zeros divided by 2.7. That comes to 370.3704. Do the same for France. 780,000 divided by 1.54. 4 zeros divided by 1.54. 506,493.5065. The country that paid more. That number is bigger than that number. France paid more. Okay. Question 18. Look at the rectangle drawn on the square grid. Draw an enlargement of this rectangle with scale factor 2. Use point A as a centre enlargement. Now, a mathematical enlargement is where the shape gets bigger, but also the position gets bigger. So the shape is going to get twice as big, and the position is also going to get twice as far from this point of the centre enlargement. So to do that, what I'm going to do is I'm going to count how far it takes me to get from here, to this corner here. Okay, here we go. I'm going to go 1, 2, 3, 4, 5 right, 1 down. 5 right, 1 down. Now because it says scale factor 2, I'm going to double that. Instead of 5 right, I'm going to go 10 right. Instead of 1 down, I'm going to go 2 down. Here we go. From that centre again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2. That corner is now that corner on my new shape. I'm going to do that again. I'm going to do it for this one this time. So going from my centre, 1, 2, 3 right, 1 down. Let's write that down. 3 right, 1 down. Again, scale factor of 2. So instead of 3 right, I'm going to double it. That'd be 6 right, 2 down. Here we go. From centre A. 1, 2, 3, 4, 5, 6. 1, 2. Remember, that was that corner there. It's become that corner there. And if you look, the top of that shape was 2 squares long. It's now 4 squares long. It has got bigger. Scale factor 2. This is doubled. Now I could do that again. I could do it again for this point here. Why not? Let's do it. Going from there. 1, 2, 3 right. 1, 2, 3, 4, 5 down. Remember, scale factor 2 means I'm doubling this. So I'm going to go 6 right, 10 down. Here we go. From here. 1, 2, 3, 4, 5, 6 right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 down. Was 4 squares long. It is now 1, 2, 3, 5, 6, 8 squares long. Now I'm not actually going to count the last one because I can see that my shape should be looking like this. You get 1 mark for making sure the shape is the right size. So 4 along, 8 along, and 8 high. And you get 1 mark for making sure it's in the right place. See here, that is twice as far away. Question 19. About 2,000 years ago, a Greek mathematician worked out this formula to find the area of any triangle. Any triangle with sides A, B and C. Area is square root of all of that, S, open brackets, S minus A, open brackets, S minus B, close brackets, open brackets, S minus C, close brackets. Where S equals A plus B plus C, all divided by 2. Triangle has sides of 3, 5 and 6. Use A equals 3, B equals 5 and C equals 6 to work out the area of this triangle. The area formula is this one. I know what A is and B is and C is. I don't know what S is. So I'm going to look at this equation first. I'll write that down. S equals A plus B plus C all over 2. Right. S equals. Now instead of A, I'm going to put in the 3. Instead of B, I'm going to put in 5. Instead of C, I'm going to put 6. All divided by 2. That means I'm going to put in my calculator exactly as it is there. Fraction button, 3 plus 5 plus 6, underneath 2. It's 7. S equals 7. So now I'm going to do this formula. I'm just going to write it all out. Here we go. S, open brackets, S minus A, open brackets, S minus B. The reason I do this is so I know exactly, and I can write out exactly underneath the numbers I'm going to put into this. I'm going to draw it out again, square root. Instead of S, I'm going to put 7. I've got a bracket. I've got 7 minus A, which is 3. Bracket. 7 minus B, which I know is 5. Got 7 minus C, which I know is 6. Now, if you've got one of these calculators, it will do all the job for you. I can press the square root symbol, 7, open brackets, 7 minus 3, close brackets, open brackets, 7 minus 5, close brackets, open brackets, 7 minus 6, close brackets. It comes up with that, 2 root 14. Now you can actually leave it like that if you wanted to, or you can turn that into a decimal, which is 7.48 3314774. Either are absolutely fine. This is called a surd. This is a irrational number. It will keep going on. The calculator stops at that point though, so you can write either in your answer box. What I'm going to do is I'm going to write this, but I'm only going to write it to 2 decimal places, 7.48. I'm going to write down here 2 decimal places because that's what I've rounded it to. That's the end of that. Question 20. Here's some information about all the pupils in class 9A. I've got girls, I've got boys, I've got right-handed, I've got left-handed. The teacher is going to choose a pupil from 9A at random. What's the probability the pupil chosen will be a girl? Well, there are 13 girls that are right-handed and 1 that's left-handed, so that's 14 girls. Just going to count up the boys quickly. There's 16 of them. 14 and 16 comes to 30. There are 30 students in total. I'm going to choose a pupil at random. So that's out of 30 pupils. What's the probability pupil chosen by a girl? Well, there's 14 out of 30. There's absolutely no reason that you need to simplify that. You can leave it just like that. If you simplify it, that's absolutely fine. In fact, your calculator will simplify it for you as well. 14 over 30, 7 over 15. As I say, you can just leave it like that. What is the probability the pupil chosen will be left-handed? Right, well, I've got 3 left-handers. I've got 27 right-handers. So again, pupil chosen out of the pupil is out of 30. And left-handed, there's 3 of them. 3 out of 30. I mean, we can leave that just like that, or we can simplify it if we want to. In all honesty, I'd leave it like that. Less chance of making mistakes because you've just left it. Part C. Teacher chooses a pupil at random. She tells the class the pupil is left-handed. Okay, so let's change things now. We know it's out of the left-handed people. What is the probability this left-handed pupil is a boy? Well, so because they've told the class it's left-handed, it's out of 3 people now. Probability of it being a boy out of these left-handed people is 2. There are 2 boys. The probability of left-handed people as a boy is 2/3. That's it. Question 21. Screens of widescreen and standard televisions look different. They have different proportions. So widescreen, it's got a ratio of 9:16. And the ratio of height to width for standard is 3:4. Harry starts to draw scale drawings of the televisions. The height is 4.5 centimetres. What should the width of each scale drawing be? If that's 4.5, the ratio is 9:16 on the widescreen. That is 4.5. What I'm looking at here is how do I make 9 4.5? I was half it. Divide it by 2. I could also divide this by 2. 16 divided by 2 is 8. Width of the scale drawing should be 8. Doing the same for this question. My ratio for a standard TV is 3:4. I've got that from up here. Height of it is 4.5. So I'm thinking, how do I get from 3 to 4.5? Well, if I do 4.5 divided by 3, I get 3 halves. Times that by 3 over 2. If I times this by 3 over 2, 1.5 times 4 comes to 6. Width of that scale drawing should be 6. Question 22. Spinner has numbers 1 to 4 on it. Probability of spinning a number 4 is 0.1, spinning a number 1 is 0.6. Probability of spinning a number 2 is the same as probability of spinning number 3. Okay. Well, all probabilities, they go on a scale from 0 up to 1. 0 being impossible, 1 being certain. Now we are certain that we will get a number. So all probabilities add up to 1. At the moment, I've got probability of 0.1 and 0.6. And if I add them up, it comes to 0.7. If all probabilities add up to 1, that means I've got 0.3 left. These two numbers. And it says they are the same. So if I halve that, probability of spinning a 3 is 0.1. If I did 0.1, 0.6, 0.15, 0.15, I would get 23. I like these. Think of a number. I'm not actually going to think of a number. I'm going to think of a letter. The letter I'm going to think of is X. I multiply this number by 8. Multiplying X by 8 gives me 8X. Then I subtract 66. Subtract 66. Result, so whatever that equals, is twice the number I was thinking of. Well, twice the number I was thinking of was X. Twice X is 2X. What I've actually just done is made a nice little equation. Line down the middle. I'm going to solve this now. First thing I'm going to do is I am going to add 66 to both sides. That makes that positive and gets rid of that negative 66. 8x equals 2x plus 66. Then I'm going to get rid of this 2x. I'm going to do that by minusing 2x from both sides. 8x take 2x, gives me 6x. 2x take 2x, cancels out, it's gone. Leaves me 66. Now I'm going to divide both sides by 6. There's 6 lots of x is 66. X equals 66 divided by 6 is 11. 11 was the original number I was thinking of. Question 24. Here's some information about A-levels in 2002. We've got, in English, number of students is 72,000. Percentage gain in the grade A is 19%. In maths, there's less students, 54,000 of them doing maths. 37% got grade A. How many more students gain grade A in mathematics than in English? So I'm going to work out what 19% of that is. And I've been teaching you to do multiplier. 19% as a multiplier is 0.19 of 72,000. 0.19 times 72,000. 13,680 students. Just going to put English there so I know it's English. I'll do this one now. 0.37. 0.37 times 54 19,980. That's maths. Just going back to the question, it says how many more students gain grade A in mathematics than in English. I'm going to take those two numbers away from each other. 19,980 minus the 13,680 gives me 6,300. 6,300 is my answer. That's how many more students gained a grade A in maths than in English. Alright, question 25. Look at this equation. 14y minus 51 equals 187 plus 4y. Is y equals 17 the solution to the equation? Yes, no. Show how you know. Well, if y equals 17 is the solution to the equation, it means if I substitute in 17 here and in here, both sides should be the same. Let's try that. I've got 14 lots of 17, just changing that to the 17, minus 51. That equals 14, brackets, 17, close brackets, minus 51. It's 14 times that 17. Calculator knows that when it's in brackets. That comes to 187. Now, if this comes to 187, we're on to a winner. And we know that 17 is a solution. 187 plus 4 lots of 17, 4 lots of that equals 187. 4 lots of 17, already know it's not going to 255. Are those numbers the same or are they different? They are different. So that side is not equal to that side. No, it is not. The sides are not balanced. Write these expressions as simply as possible. 9 minus 3k plus 5k. Right, there are no other integers on their own. I'm just going to put my 9 in now. For minus 3, add 5. Minus 3, add 5. 2. 2k. This one. I've got no other squareds, no other k squareds. I'm just going to write that k squared in here. And I've got positive 2k, I've got 2k's, add another 4k's. 2 add 4 is 6, that's 6k. Here I only had one integer, so I wrote that in, and then I sorted out my k's. Here I had my only k squared, so I wrote that in, and then I sorted out my other k's. That is the end of the test. I hope that was helpful.